Now, one unit of measurement we should talk about is hertz. It shows up all over the place when we're dealing with audio, so the sooner we take a look at it, the better. The best way to think of hertz is that it represents the number of times an event is completed per second, or the number of cycles per second. It represents different things in different situations, but it always refers to a certain amount of events per second. Now, the two places you'll find it in dealing with audio very commonly are with frequency or pitch, and also with sample rates. Hertz is represented by a large h and a little z, and then a few prefixes. For instance, in our chart we have 1 hertz, or 1 cycle per second, 1 kilohertz, or 1,000 cycles per second, 1 megahertz, or 1,000,000 cycles per second, and 1 gigahertz, 1,000 million cycles per second. Let's talk about how hertz relate to frequency next. When we talk about hertz in relationship to the frequency of a sound, we're talking about the number of times a sound wave completes a cycle per second. The higher the frequency, the higher the pitch. So let's look at these graphics. First we have a complete cycle of a sine wave. On the left we have it in a linear display, and on the right I've slid the bottom half around just to illustrate that a cycle means a complete revolution, or once around, so to speak. Down below we have several different frequencies and their sine waves. On the left we have the frequency, and in the middle we have one cycle of that frequency, and then on the far right here we have all three frequencies against the same amount of time. Now you can see that the higher the frequency, the shorter the cycle, and therefore the more cycles that take place per second. Now we can see that there are quite a few more cycles per second at 6 kilohertz than at 1 kilohertz. So again, frequency refers to the number of times a sound wave completes a cycle. Now let's look at what we call the range of human hearing. The human ear is capable of hearing frequencies that range from the very low-pitched 20 Hz to the very high-pitched 20 kHz, or 20 to 20K. Sounds that exist above this range are referred to as ultrasonic, and those that are below it are considered subsonic. Now in audio production, we tend only to concern ourselves with the human range of hearing, this 20 to 20K range. Now, if you were making music for dolphins or doing a podcast for bats, you would want to include frequencies all the way up to 200 kilohertz because they can actually hear that high. But humans, perhaps like you and I, can't hear beyond 20 kilohertz. So that's what we tend to worry about. Now, when we work with audio, we tend to break this range down even a little bit further, kind of to simplify things into 3 subcategories. We call them the lows, the mids, and the highs. And as you would expect, the lows refer to the lower frequencies, the mids to the mid-range frequencies, and the highs to the higher frequencies. A little side note on the range of human hearing, most of us don't hear that much above 16 kilohertz, even though the range goes up to 20K. And actually, as we get older, we hear even less than that, which is why kids can set their cell phones to ring with these really high-pitched ringtones, and when they go off in class, the teachers can't hear it because their hearing's not as good as it used to be. And everybody says kids are stupid. And that provides a pretty nice segue into talking about frequency response. Frequency response generally refers to how sensitive a person or a microphone or a device is to different frequencies. This is often represented in a graph, and it's well worth understanding because you're going to come into contact with this quite a bit when you look at different specs for gear and equipment. What the graph will show is the frequencies along the x-axis, and then the response to those frequencies, or the sensitivity, along the y-axis. So this top chart shows a flat frequency response. Now, in other words, it represents equal sensitivity to all frequencies. And when it comes to audio recording equipment like microphones and speakers, a flat or accurate response is very favorable because it can help us achieve accurate representations of the sound. But in reality, humans, and very often devices, don't actually have flat, accurate frequency responses. It's actually quite difficult to manufacture a device with a flat frequency response. So below we have a chart showing an uneven frequency response. In other words, it shows different sensitivities to different frequencies. And this is much more like what our frequency response probably looks like as humans. We're a little more sensitive to some of the frequencies here around the 8K range, and then we have quite a drop-off in sensitivity when it comes to the extremes of the range of human hearing. So that's basically it for hertz, frequency, the range of human hearing, and frequency response. To recap, hertz, which is signified by a big H and a little z, refers to the number of times a cycle or something happens per second. When we talk about hertz in relationship to frequency, we're talking about the number of times a sound wave completes a cycle per second. The range of human hearing is a frequency range of 20 hertz at the low end up to 20 kilohertz at the high end. And finally, frequency response refers to the range of frequencies a person can hear and how sensitive they are to those frequencies. And we can use charts to represent the frequency response of different things, such as speakers, microphones, people, dolphins, bats, wombats, you name it. Next, we'll talk about phase.